Tamil Nadu, India, and I have given my mail ID. So in today's session, I have been given with the topic machine learning techniques and its applications. Am I audible? Any one of you, please give it in the chat window that I am audible or not, so that I can proceed further. Am I audible? Okay. Thank you. So without much delay, let me proceed to the topic machine learning. Actually, what is machine learning? Whether learning about a machine or how it is related with computer science and what this technique really means. Actually, machine learning techniques or machine learning algorithms means making the machine to learn something about something which can help the human beings for making out in decisions. So we are going to make the machine to learn so that it can come out with the predictions. Say for example, I have given a data set in the screen. So this data set is actually the data set of a cancer, say some 10 persons health issues. See, this is customer, what I can say, this is patient's data set. So this data set contains patient ID in the first column. So first column contains patient ID and so many attributes related to their cancerous cell. So upon analysis, the final last column says whether the patient suffers from benign cancer or malignant cancer. So this diagnosis is given by a physician, I can say. And suppose we are expecting the same help from the computer so that in the absence of any physician, the system should come out with good prediction. Whether if it is possible, then this can be done through machine learning algorithm. So as a conclusion, I can say machine learning helps the human being with predictions, right? So 10 set of data set already we have. And this data set will be modeled using machine learning algorithms. And the unknown data set, if we are giving to the machine learning algorithm, it will come out with the prediction that whether it is benign cancer or malignant cancer. So machine learning, I can say it is a type of technique which helps the human being to come out with the predictions, so that some data set should be given and that data set should be trained by machine learning algorithm. So this is a small introduction about machine learning. Here we have some other example. We have some 5 different data set. That is a data set of patients with various characteristics: age, sex, BP, cholesterol, their sodium and potassium level, and what the drug can be prescribed to each and every patient. So this, it has been stored by a physician, and in the absence of physician, this data set, if it is trained to or it is trained by machine learning algorithm, in the absence of any physician, this particular machine learning algorithm can support a human being to come out with the prediction. So predicting the right drug, this is also one of the application. And machine learning can help us to come out with decisions. So how decision making can be expected from machine learning algorithm. See, this is a customer data set, and we can categorize the customer into category 1 or category 0. So it will find out some commonality between the data set, and machine learning algorithm will generate its own idea to categorize the data set into category 1 or category 0. And if any new record is given as input, then it will post that new category into either 1 or 0. So it comes out with making decision, and it supports in categorizing also. This is also one of the machine learning application. And we have customer segmentation in this slide. So as I said, customer data set is already given. It contains age, education, years employed, income, debit card, credit card, address, debit income ratio. And based on these parameters, the customers can be categorized into category 0 or category 1. How this will be done? So based on some characteristics identified among the customers, machine learning will find out some logics in separating them into category 0 or in category 1. So it will be categorizing into 0 category and 1 category, and if any unknown record is given, so again for that unknown record, it will find out some mechanism, and it will place that unknown record into either 0 or 1. So this is called as customer segmentation. And one more very important application of machine learning is it supports recommendation system. So what is recommendation system? All of us, we may be using Facebook, or say for example, I'm using Facebook. And let me take an example of purchasing items through Amazon. So if I'm frequently purchasing any particular item, then the system will come out with its own recommendation of giving some suggestion of similar items. So it will match my likes, or it match my interest of purchase, and it supports with some recommendation. So this is also one of the popular application of machine learning. So let us see some important algorithms of machine learning, and we'll get the concept of how machine learning works. Okay. So with this preliminary idea, let us go into the topic. What is machine learning? So machine learning, it's actually the subfield of computer science that gives computers the ability to learn without being explicitly programmed. It is unlike traditional programming, but it uses some algorithms and some training methodologies for making the things done. How does it work? So it identifies some features from the data set, and it implements certain set of rules, and then it comes out with predictions or categorizations or segmentations, etc. So this is our previous traditional method. Feature extraction will be there, set of rules will be there, and finally outcome will be possible. But here, machine learning model will find out some training. So whenever we are supposed to learn about machine learning algorithm, we should know how training happens. So machine learning means it accepts database as input, and the database will be trained. So based on the trained data set, the unknown data set can be given as an input to the trained data set, and it can come out with predictions. So major machine learning techniques, we have anomaly detection, sequence mining, dimensionality reduction, recommendation system, and the application. Also, with respect to various techniques, we have n number of applications as well. Okay, what is the difference between artificial intelligence, machine learning, and deep learning? So artificial intelligence is a general case where we can have computer vision, natural language processing, even we have deep learning, all the other things. But machine learning, it's a subcategory of artificial intelligence. So in machine learning, we'll be having classification algorithms, clustering algorithms, and we have reinforcement learning algorithms as well. And again, the subset of machine learning is going to be deep learning. Okay, so let us make a little bit higher about, let us go in deeper about machine learning. So machine learning algorithms, broadly, if we classify, it comes into two categories: supervised learning or unsupervised learning. So generally, machine learning means it accepts data sets. It gets trained using the available data set and come out with some predictions. And in the data set, if we have any labeled column, then that type of data set will be given for supervised learning. So I can say for example, let me revisit the example. So let me take this data set. So this data set contains the information about some 10 patients. So we have ID, we have clump, unit size, so many attributes we have, and finally we have a class called as class. So class gives some categorization about or the classification or labeling about the data set. It labels each and every row as a benign cancer patient or as a malignant cancer patient. So this acts as a supervisor or acts as a guide to the database. So it has given some guidance to the user that based on these inputs, this data set can be categorized or classified. So if such guide is there in the data set, then we should go for classification algorithm. So what is classification? Classification is a special type of supervised learning. When we can go for supervised learning, if a data set contains a labeled column which acts as a supervisor, then we can go for supervised learning. And we have two types of supervised learning algorithm. One is classification and next one is regression. So what is the difference between classification and regression? If we have categorical values in the data set, then we should use classification algorithm. And if the data set is of numerical type, that to continuous numerical value, then we can go for regression. So this is with respect to supervised learning. Again, if the same data set is not having any labeled column in it, then we have to go for unsupervised learning. So under unsupervised learning, we have the very famous algorithm called as clustering. So supervised means the data set should have a labeled column. Unsupervised means the data set need not have a labeled column. So under supervised learning, we have two branches of algorithms, classification algorithms and regression algorithms. And under unsupervised learning, we have clustering algorithms. So again, we'll go in detail about supervised learning. So what is supervised learning? We teach the model or we train the model so that the model can come out with some predictions. Is it okay? As I said, we have two types of algorithms, classification algorithms and regression algorithms in supervised learning. What is all about classification? Classification means we are going to segregate into, see, if you have so many dots and plus, then dots and plus will be segregated using this line. So classification will divides or segregates or partitions based on the nature of or categories of the values that are available in the data set. And regression means it will find out some uniformity, it finds some regression commonality in data set, and an ideal regression line will be drawn on that data set and which can come out with predictions, right? I'll say that concepts in detail. And both classification algorithm and regression algorithms comes under supervised learning because both these algorithms will have a labeled column in it. Okay. So let us discuss in detail about the first type of machine learning algorithm called regression. So what is regression? It's a process of predicting continuous values. So if we are given with the data set And we are supposed to identify what type of algorithm to be used for that particular data set. Then it is possible if we go for analyzing the data set. Say in this example, you are given with a data set containing 4 attributes. First attribute is engine size, second attribute is cylinders, and third attribute is fuel consumption, and fourth attribute is carbon dioxide emission. From the data set, we can identify that this is about some heavy duty vehicle. Say it may be a car, or it may be a lorry, or it may be some vans or other thing. And assume a manufacturing company, they have stored the database of the vehicles manufactured by them, and they have given the data set of each vehicle. If the engine size is 2.0 and the number of cylinders is 4, and if the fuel consumption combustion is 8.5, then the carbon dioxide emission is 196. Similarly, for 10 different vehicles, they have stored the attributes in the data set like this, right? And suppose if we are given with a query, so what is that? What will be the carbon dioxide combustion if the engine size is 2.4 and the cylinder is 4, fuel consumption combustion is 9.2. If that question is asked as a testing to this database, then first step, we are going to use this data set as an input to machine learning algorithm. So we know we have 2 types of machine learning algorithm. First one is supervised learning, and second one is unsupervised learning. I have explained clearly that if you go for supervised learning, then that particular data set should have a labeled column. Out of all these 4 parameters, we can infer the target or the label in this data set. The carbon dioxide emission is going to be the target value, the target variable or target attribute or the labeled attribute, because we are asked to find out what would be the carbon dioxide emission for the engine size of 2.4, cylinders 4, and fuel consumption combustion 9.2. So we are asked to predict the unknown output. In such a case, we can go for analyzing data set. Because it is a labeled data set, definitely it is possible to go for supervised learning algorithm, right? And again, supervised learning has 2 categories. First one, a regression, and second one, classification. I have clearly explained, if the data set has continuous numerical value in the target or in the labeled value, in the labeled column, then you can go for regression. So in this case, as the carbon dioxide emission has continuous numerical value in it, and as we are asked to predict that value, we can go for regression. Okay, how we can find out this, how we can go for this prediction? So we should use some regression concepts. So we are taking, or we are supposed to draw a regression line. How this line can be drawn? What is this regression line means? This is an ideal line which passes through the majority of the points in the given set. How these points can be generated? It is easy to plot each and every record as a point. Say, for example, I am taking the 0th record with the 2.0, the engine size in x-axis and carbon dioxide emission in y-axis. So I am plotting 2.0 against 196. So we have a dot in this graph. Again, the second record, we have a second dot, third record, third dot, fourth record, and so on. So how many records you have? That many number of dots you have in the graph, right? Then I should draw an ideal line called as a regression line, which passes through the almost covering all the points in the graph. So this line will be called as an ideal line. Let me move. See, that many number of dots we have, and we have a regression line. That line passes through all the points. How this line can be drawn, we'll discuss later. So once this line can be drawn, we can predict the unknown output. How we can predict? So again, engine size is taken as 2.4 for the unknown record 2.4. So for 2.4, I am going to intersect with the regression line, and we are finding out, and we are hitting that with the y-axis 214. So 214 will be the 214 will be the value for the unknown output. So the system or the machine learning algorithm has come out with the prediction that 214 is the value for the new record number 9 with the engine size of 2.4. Is it okay? So this is how regression works, right? So when the record set is given to you, you are supposed to convert the record set into points, and we are supposed to draw an ideal line called as a regression line, which passes through the majority of the points, and the unknown record can be identified using this ideal line. So this is how regression works. How this regression line can be drawn? By using the equation of the straight line, y-intercept plus slope into, that is y equal to mx plus e. See, that is theta naught is the y-intercept, theta 1 is the slope, and the corresponding x coordinate. So this is how the line is drawn, right? If we know the slope and y-intercept, we can draw the entire equation. So this is we have once. So this is the formula for drawing the line. We will be taking. We have to find out theta 1. We have to find out theta naught, and once we find out theta 1 and theta naught, we can draw this regression line. And once the regression line is drawn, then we can go for the prediction of unknown values. So this is about the linear regression. Of course, we have multiple linear regression, because why this is called as linear regression? If we are taking only engine size and carbon dioxide emission, only one x-axis and only one y-axis, then it is called as linear, that is simple linear regression. If we are accounting more than one variable, like the cylinders, fuel consumption, other thing, more than one input parameter, then we can call it as multiple linear regression, right? And how performance can be measured? So we have the data set, and whatever data set we have used for training, it is called as training data set, and some of the data set can be used for testing also, that is called as test data set. And we are supposed to compare the outcome of trained value with that of testing value. So here 232, 255, 269 and 212 are the values used from training data set. And the same values can be used for testing also, and we have to find out the difference between actual output and the test output, and that difference will be called as errors. So if we have the summation of error, then it is called as mean error, and if we are finding the square of the error, then it is called as mean square error, and if we are finding the square of the difference of errors in rooted value, then it is called as root mean square error. And so many techniques are there to separate the train and the test data set. So if this is going to be the entire data set, and if we are dividing some of the values, that is all the values for training data set and some of the values for testing data set, then it is called as that type of data set will suffer from high training accuracy and low out of sample accuracy. And we also have train test split evaluation approach, where if this is going to be the entire data set, and some portion of the data is used for training and some for testing, then that type of data set will suffer from out of sample, that is accurate on out of sample accuracy, and it suffers from highly dependent on which data set is trained and tested data set. And we can also use K-fold approach. That is, we can use multi-fold for training and the remaining data set for testing. So this is called as multi-fold cross-validation approach. So with this, I think I have covered a little bit of regression. Let me go for the next type of supervised learning algorithm called as classification. After lunch, you can come and so we can go for classification algorithm in supervised learning. Again, if we repeat, machine learning algorithms is broadly classified into supervised learning and unsupervised learning. If the data set contains labeled columns, then we can go for supervised learning. So under supervised learning, we have regression and classification. If the database contains continuous numerical value in the labeled column, then we should go for regression techniques. If the labeled column contains categorical values, then we can go for classification. So what is classification? It is a supervised learning approach. So categorizing some unknown items into discrete set of categories is called as classification. So coming to the example again, we are given with the patient database and we are supposed to categorize the patient into benign cancer and malignant cancer patient means, then we have to go for classification algorithm. How we can identify that classification algorithms should be used for this particular data set? Because the last column, class, is having categorical values instead of numerical values. If you have continuous numerical values, then we should go for regression. If the labeled column has categorical values, then we can go for classification algorithm. Here, we are supposed to apply classification algorithm for categorizing this patient data set into benign cancer patient or malignant cancer patient. We have n number of algorithms for classification. So how classification works? The data set should be given as a training or modeling sample to the classifying algorithm, machine learning algorithm. Once the model is getting trained, once the training is over, then the model is ready for accepting unknown inputs. Say, for example, if the unknown input with the age of 37 and with so many characteristics are given to this trained model, then the machine learning model will come out with the prediction that whether it belongs to category 0 or 1. This is how the machine learning algorithm responds with classification. So this type of model, we call it as classifier model. Okay. Again, we have one more example. This is a patient with so many attributes like age, sex, BP, cholesterol, sodium, potassium. And say the physician, they are prescribing drug Y, C, X, and so on. So this particular data set can be categorized into drug Y, drug C, and drug X, right? So this algorithm should apply classification techniques because the labeled column drug has discrete values in it, right? So a classification algorithm works on this particular data set and it trains, it gets trained using this input model, and a classifier will be built. Once the model training is over, this classifier will accept any unknown input and it can come out with a prediction. So how it can predict if an unknown input age 36 female, low BP, cholesterol, potassium, sodium, and so many attributes are given as an input to this particular classifier, the system will come out with the prediction of label like drug X can be suggested by this algorithm. Okay, this is how classification algorithm or classification algorithm works. There are some use cases I have shown here. So you can use classification algorithm for these type of problems, like which category a customer belongs to, whether the customer switches to switches to another broadband provider or not, whether the customer responds to particular advertising campaign. So for these type of use cases, we can go for. So if you are given with the data set like this, and for these use cases, you can go for classification algorithms. Some of the famous or very popular classification algorithms in machine learning: decision tree, naive-Bayes algorithms, linear discriminant analysis, k-nearest neighbor algorithm, logistic regression, neural networks, and support vector machines. These are some of the very popular classification algorithms which shows better performance, right? So for easy understanding, let me explain at least one algorithm in detail so that the other we can understand by our role. So let me go for my explanation about k-nearest neighbor algorithm. It is also called as KNN, right? So let me give some idea about k-nearest neighbor algorithm. And I have taken the data set of a broadband customer, that is customer data set, which depicts the broadband usage. So it may be a broadband provider who have stored the database of customers. Say, I have different database, 0, 1, 2, up to 7. So totally 8 record set we have with so many attributes: region, age, marital status, address, income, education status, employment, retirement, whether retired or not, gender, residence, and I have a column called as customer category. So out of all the columns or out of all the attributes, I have a column called as customer category because this column is, or this label or this particular attribute is going to guide me in coming out with the predictions or coming out with some guidance or something. It is going to act as a supervisor. So that column can be called as a dependent variable. All the other attributes, we call it as independent variables. Always the target column, we call it as dependent variables or a labeled variable, or we call it as a supervisor variable. In any name, we can call this target variable. And the remaining variables or the remaining attributes, we call it as independent variables. And suppose if we are given with an unknown record, say record number 8, which has 3 in the region, age 50, so and so, and if we are asked to predict the customer category, then this database can go for KNN algorithm. So KNN algorithm comes under classification algorithm of supervised learning, right? So how KNN works? It is going to categorize the entire set of records into category 1, 2, 3, and 4. So some set of records will be in the group of 1, and some set of records will be in the group of 2, and some set of records will be in the group of 3, and some set of records will be grouped under 4. The unknown record, we have to apply the classification algorithm KNN to find out in which category the unknown record belongs to, right? So we'll see how KNN helps in identifying this categorization, right? Again, we'll go for KNN algorithm. So we have taken two columns, age and income. Age in the x-axis and income in the y-axis. And if the first record belongs to category 1, and I have plotted this in a graph with the color blue or color violet, I can say. If the record belongs to the category 2, then it is given a blue color. If the record belongs to the category 3, then some light green color is given. And if the record belongs to category 4, then I have given some purple color. So this how we have differentiated the categories 1, 2, and 3. So say assume record number 0, we have 44 as age and the income as 64. And some plots we have, some dots we have in this graph. Similarly, if we have 100 records, 100 dots with different colors, it will be plotted in the graph, right? And now we are supposed to identify what should be the group or category of this unknown record, right? Suppose if we have the unknown records age as 50 and income as 166, and assume it comes somewhere here. So I have given question mark here, no? So that will be the place of this unknown record. Then I have to come to a conclusion, this question mark, whether it should be given or it should be given with the color of 1 or 2 or 3 or 4, right? So your KNN would suggest or recommends for giving a suitable appropriate color, or I can say appropriate category for this question mark. So let us see how KNN works for recommending the suitable category for this question mark. Okay, so KNN, by the name itself, we can justify it is near, it will be finding nearest neighbor, right? K nearest neighbor. K stands for any random value from 1 to n. Say here in our example, I have chosen 5 as a value for K. So this is 5NN. If 5NN is applied for this particular problem, then I have to find out 5 nearest neighbor that is situated around this question mark. So this question mark is surrounded by some 5 nearest neighboring dots. So out of 5 nearest neighbor, I can identify 2 purple dots and 3 green dots. So which says the majority of the neighbors are green. So what is the category of green? It is category number 3. So I can say the majority of the neighbor will be the one I can suggest for question mark itself. So I can go for recommending, or my KNN would go for recommending green as the color for this question mark, because the majority of the neighbors surrounded by it is only green. So out of 5 nearest neighbor, 3 neighbors have the green color. So green should be the color suggested for question mark. So that's how it decides, right? So this is the algorithm for K nearest neighbor. Pick a value for K. Calculate the distance of unknown case from all the cases. Select K observation. In our case, we have chosen 5 cases. And we have to identify 5 nearest neighbors situated around that particular unknown data point. And among those 5 nearest neighbors, I have to select the majority of responses, and that majority would be the suggested value for this unknown point. This is how K nearest neighbor algorithm works, right? Again, for the same data set, we can go for calculating accuracy. You have so many metrics for justifying the accuracy. We have Jacob index. So how Jacob index works? So based on the actuals and predicted values, suppose if y is actual value and y cap is predicted values, we'll find out the intersection y cap divided by y union y cap to find out the accuracy. If higher the Jaccard value, then we can say higher the accuracy. Then we have a measure called as F1 score. For that, we have to draw the confusion matrix. This confusion matrix will divide the data set into 4 columns, that is true positive, true negative, false positive, and true false negative. So we have a formula for calculating precision and recall and F1 score. Precision will be true positive divided by true positive plus false positive. And recall would be true positive divided by true positive plus false negative. And F1 score, it is 2 into precision into recall divided by precision plus recall. This is how the F1 score can be calculated. And we also have log loss. So this also finds the difference between the actual labels and predicted labels. We have 0 to 4, we have some 5 records as actual values, and for the same 5 records, if we have some predicted values, that we have first step, we are going to find out the differences, and we'll apply the difference in this log loss formula. So log loss would be minus 1 by n sigma y. What is y? Y is actual label into log of y cap. It is log of the predicted value plus 1 minus actual value into log of 1 minus predicted value. So if you apply on the values on this formula, we'll find out, we'll have the log loss of all the values, and finally we'll sum. And as the name suggests, if log loss is lesser, then we can say higher the prediction. So these are some of the what I can say, it is metrics for finding out the accuracy. So this is how we'll find out the performance of any algorithm, any machine learning algorithm. So we can use either confusion matrix, log loss, or we can go for Jaccard index. So mainly it works on the error between actual value and the predicted value, right? So we have seen what is supervised learning, and under supervised learning, how a regression algorithm works and how a classification algorithm works. And we have n number of algorithms under both regression methods and also in classification. I have explained only one algorithms under each concepts in detail, right? So with this, I think we have decision tree also. Decision tree also, it's one of the famous algorithm under supervised learning, that too classification algorithm. If time permits, we can go in detail with decision tree. So as of now, do you have any doubts? You can say it in the chat window. Yes, do you have any doubts? So we have completed our discussion on supervised learning. Data is the foundation of machine learning, but not all organizations have access to high quality data. How does data availability and quality impact machine learning performance, and what solution exists for addressing bias in data set? Actually, the question of machine learning algorithms comes only through the predictions of data set. Only if the data is available. And one solution I can suggest for this question, instead of giving the full access to the complete data set, the company, if they are very particular on maintaining its confidentiality, they can go only for providing some of the views. Say, if a data set contains some 25 columns, it is better if they are able to provide at least some of the columns, say column number 1, 2, and the target column, instead of giving all the columns. That is one of the solution. And again, coming to the data set, instead of giving, say, for example, if that particular data set contains some 20,000 records in it, instead of giving all the 20,000 records to the data science engineer, they can provide only a portion of data set so that we have our work done, right? This is, and one more solution also we have, instead of giving live data, we can have a simulated data. So with that simulated data, we can go for training this machine learning algorithm, and we'll give that trained model to them. And again, the company can go with their original data set. But anyway, getting data set is mandatory for the machine learning. That is, machine learning model gets trained, right? So this is what I could suggest. Hope I have answered your question. So data is, it should be the foundation, but if the organization is very particular about their confidentiality, simulated data or dummy data sets can be given to the data science engineer who are developing machine learning algorithms, which can come out with a good training, good classifier, and a good model. And that model can be deployed in the organization, and they can run with their original data set. Is it okay? Hope I have answered this question. Any other question? Okay. I think I can proceed with the next type of algorithm. Okay. We'll come again to decision tree if time is there, because decision tree is one of the supervised learning algorithm that comes under classification. Already we have discussed about one of the classification algorithm, K nearest neighbor algorithm. So better we can move to the second type of machine learning technique called as unsupervised learning. Is it okay? So let me revisit. When a database is given to you, how you can predict whether you have to go for supervised learning or to go for unsupervised learning. It's always better to analyze the data set. If the data set has any labeled column in it, which can come out with the predictions, which can act as a supervisor, then we can go for supervised learning algorithm. If a data set is not having any such supervisor or a labeled column, any distinguished attribute which can guide us in making predictions or categorization and other things, then we can say it is mandatory to go for unsupervised learning. You can come after the lunch. Sorry, I was caught up by some academic. Sorry for the disturbance. So coming to unsupervised learning, assume you are given with the database like this. So this is a customer database which has customer ID, age, education, so many attributes are there. And we are not given with any guidance about the target. This customer, whether they belongs to any category or anything can be predicted with this data set. We don't have any idea about this data set, about the categorization, classification, or a target, or some what is meant by target. So in the example, we have seen about carbon dioxide combustion, and we are given with a target there, but here we don't have such as targets and other things. But simply we have given with some columns and rows, that's it. And suppose we are given with a problem to cluster this based on some similarities. Say this is about the customers of bank, I can say. So the bank, they have decided to categorize this customer data set into a promising customer, or with some credit ratio very poor, that is, I can say CIBIL score, very poor CIBIL score, or based on the customer category, if they wish to provide a loan to the customer, and some categorization if needs to be done, and if this problem is given to a machine learning algorithm, so that this machine learning algorithm has find out some similarity among the customer data set provided to it, and such a similarity needs to be identified by the machine learning without any supervisor or guidance, then we should go for unsupervised learning algorithm. And again, unsupervised learning algorithm, the very famous technique is clustering technique. I'll say how does it work. So cluster, that means we are going to form groups of objects that are similar to other objects in the cluster and dissimilar to, I can say, inter-cluster property should be maximum. Intra-cluster property should be maximum, and inter-cluster property should be minimum. Say, in this example, cluster 1 is there, cluster 2 is there, and cluster 3 is there. And cluster 1, inside cluster 1, we have given green dots, and inside cluster 2, we have given red dots and blue dots. I can say these green dots should not have some similar properties with that of the items belongs to cluster 2 or cluster 3. But it should be more cohesive in exhibiting their properties within the cluster. So I can say intra-cluster properties should be maximum and inter-cluster properties should be minimum. Is it okay? Then, generally, what is clustering? It is used for segmentation. See, this data set, what is being given to us, has been segmented into blue category, light blue category, and a red category. What is that light blue category means? It is cluster number 1. And the bank has named cluster 1 as affluent and middle-aged customers. Cluster 2 is young-aged and middle-income customers. And cluster 3 is young-aged and after the lunch. So cluster 3 is young-aged and low-income customers. Is it okay? So how it has categorized into 3 clusters? Whether only 3 clusters are possible, why not 5? Why not 7? That may be also the question. So if we are if the customer or sorry, if the end user wants to divide this entire data set into 3, then machine learning algorithm will find out some properties to make it possible to categorize them into three categories or 3 clusters. If you are giving the input size as 5, then the entire data set will divide this database into 5 categories. So this is how unsupervised learning works. So arbitrary number of clusters can be formed using clustering algorithms. Once this cluster has been identified, and if any unknown record comes, and this unknown record will be given as an input to the classifier, and the classifier comes out with a prediction on to place the unknown record set under which category or group. Is it okay? So let me say the difference between clustering and classification. So classification, of course, it has a labeled column, and that labeled column will guides in separating into so many groups. Here, same data set can be given to unsupervised learning algorithms. Here I have we have taken the same data set and identified the last column as a labeled data set. And if I am identifying one of the column as a labeled data set and using that data set as a supervisor for training, then I should go for supervised learning algorithm called as classification. And if the same data set, I'm not using any supervisor, but giving the entire data set to the machine learning algorithm directly, then that machine learning algorithm will find out some mechanism of categorizing into so many clusters, and it provides segmentation of the existing data set. So here it comes out with segmentation, right? So classification comes out with the predictions, and clustering comes out with segmentation. So this is how classification and clustering algorithm differs, right? Again, one more inference you can observe. Customer ID 1 with the defaulted 0 and customer ID 4 with the defaulted 0, they are in different categories, right? But in classification, they both belong to the same class called as class 0. But here, even though we have defaulted value to be same, it comes in different categories because the machine learning algorithm will find out some properties within the data set, and it categorizes the entire data set into different segments, and the segments will be given as an output to the end user. Is it okay? So very famous algorithms we have come across, like K-means clustering, K-median clustering, fuzzy Z-means clustering, right? So both hierarchical clustering we have, and also partition-based clustering we have. And we have one more clustering called as density-based clustering, right? In hierarchical clustering, we have agglomerative clustering and divisive clustering. Density-based clustering, we have DB-scan clustering, right? These are all some of the reputed clustering algorithms. Still, it is being used in researches. And what are the use cases for clustering, and what are the applications for clustering? We can use clustering algorithms for retail marketing, that is identifying the buying patterns of customers, and we can also use some recommendations, that is recommending new books based on our interest, and in banking sectors to identifying the fraudulent customers or fraud detection in credit card use this clustering can be used. Clustering algorithms are playing a vital role. And we also have the use cases in insurance. So based on the CIBIL score at the existing database, fraud detection and claims analysis can be done. The issue of insurance and the risk of customers, that is also possible using clustering applications, right? 3 more also here. We have publication, that is auto-categorizing news based on their content, recommending similar news articles, that is also possible. And in healthcare, we have categorizing the patient behavior, and in biology, we have clustering genetic markers to identify family ties. So these are all some of the reputed applications. In clustering, the very famous algorithm is K-means clustering. We'll go for understanding what is K-means clustering, how does it work. Okay. So, assume you are given with the data set, say the example we have already seen is customer data set, which contains customer ID, age, their educational status, years employed, income, credit card, debit card, address, debit income ratio, defaulted, so many attributes, and assume you have some 9 records. And we are given with the problem of segmenting this 9 into 3 categories, cluster 1, cluster 2, and cluster 3. How is it possible? This data set will be fed as an input to the machine learning algorithm, say a clustering algorithm, and this clustering algorithm will find out some similarities, and say K-means clustering will be applied on this data set, and 3 categories it has been segregated, and with so many cluster sizes. So we have trained this model, and this algorithm is ready. And an unknown data set, if it comes and it is fed as an input to this machine learning trained model, then this model will come out with the prediction of suggesting in what cluster the new record can be placed into, right? This is how K-means clustering supports us. Let us see how K-means clustering works, right? Again, we'll go for understanding this K-means clustering with an example. You have customer ID, say 9 IDs you have been given, and you have age, income. Again, you are going to plot, for the understanding purpose, I'm using this plotting concept. You are going to have an x-axis and a y-axis. Say you have taken income in x-axis and age in y-axis, and you say if you're having some 50 records, all the 50 records are plotted based on their age and income. So this how the graph looks like, right? See, 50 records have been converted into 50 plots, and now these 50 plots should be converted into 3 clusters, 3 groups. All these 50 records should be categorized into 3 groups. Let us see how K-means clustering algorithm works for categorizing this 50 records into 3 groups, right? So K, again, it's a random number. For our example, let us assume we have taken the value of K as 3. So initially, we are supposed to choose 3 centroids, as we have K as 3, as we have assumed or initialized the value of K as 3. First step is to assume 3 centroids, C1, C2, and C3 randomly in that space, right? We have plotted 50 dots in our space, and in that space, we are supposed to choose any 3 random dots and call it as C1, C2 and C3. This is step number 1. And the second step, we are going to find the distance between each centroid with that of all the points. Say each and every centroid and the distance between that centroid to that, see each and every point, and say this is point number 1. I have to find out the distance between point 1 with that of centroid 1. Distance between point 1 with that of centroid 2. Point 1 with that of centroid 3. And that should be tabulated here. So distance between point 1, centroid 1, point 1, centroid 2, point 1, centroid 3. Again, say for example, I'm having 50 points. Then for each and every point, I have to tabulate its distance between centroid itself and centroid 1, itself and centroid 2, and itself and centroid 3. That should be tabulated. So this is step number 2. And step number 3, I have to associate each and every point to the closest centroid. Say for example, point number 1, it is very closest in distance. It is having very minimum, smallest distance with that of centroid 1 when compared to centroid 2 and 3. Then I have to associate that point to centroid 1. Similarly, every point should be associated or should be linked to any one of these 3 centroids. It should be associated to either C1 or C2 or C3. If a point 5 is having smaller distance to centroid C2 when compared to C1 and C3, then 0.5 should be associated to centroid 2. Is it okay? Similarly, all the 50 points should be labeled by giving either C1, C2, C3, right? Any one of the 3 points which is very closely associated, that should be assigned to each and every point. This is step number 3. And based on its association, initially we will be having 3 different groups. That is a group C1 with the centroid C1 with all the points associated to it. And again group C2 with the centroid C2 with all the points associated with that centroid. And a group C3 group with the centroid C3 with all the points associated with that centroid C3. This is how initially we'll have 3 different categories, right? Again, these 3 can be called as 3 clusters. Whether this is ideal cluster? No. We have to go for fine-tuning this cluster or this categorization, how it is possible. So this is, we have completed 1 iteration. And we have to go for second iteration by checking whether that centroid is going to be the ideal centroid in that group. Say in group 1, in the C1 group, whether that C1 centroid is the most accurate centroid among all the points available in that group. So we'll find out the new centroid in that group. Again, in cluster 2, we'll find out new centroid, and in cluster 3, we'll find out again new centroid. So if new centroids are possible, then we have to go for second iteration, right? In this case, C1 is not going to be the new centroid for the second iteration. We have nominated some other new centroid. So C2, we have some other new centroid, and C3, again, it is not going to be the one and the same. For the group 3, we have identified new centroid. If new such centroids are available, we have to go for some more new iteration. Is it okay? So once we have identified new iterations, Again, the same process should be repeated. So what is the same process? What is the step number 2? First step is identifying the centroid, and second step, identifying the distance of each point with respect to C1, C2, and C3. So that we have to find out and update the tabular or update the table here. And step 3 should be to link all the points with that of the nearest or the closest centroid. So again, a new type of clusters will be found out. And once we have a new cluster, we'll go for identifying the new cluster again. So this process is repeated again and again until no more new clusters or no more new centroids are found out. Right? This is how K-means clustering works. Right? So this is how we have identified clusters among the data set. So how does K-means clustering algorithm works? Randomly placing K centroids, one for each cluster, finding the distance of each point from each centroid, assign each data point to its closest centroids, creating a cluster, recalculating the position of K centroids, and repeating the steps 2 to 4 until no more centroids are identified. Right? Okay. What would be the ideal value of K? Yes. I can hear some voice from you, whether you have any doubt. So if you have any doubt, you can post it in the chat window so that I can answer. Yes. I can proceed. So in K-means clustering algorithm, in our previous example, we have chosen the value of K as 3. Whether 3 is going to be the ideal value of K? No. So how we can identify the ideal value of K to identify the best clustering? So we'll keep on increasing the value of K and finding the performance, and one point will have a elbow point. That will be the ideal value of K. So whenever we go on increasing the value of K and finding the distance of that data point to be to cluster centroid, and in some case we'll have a elbow point that could be the ideal value of K. Is it okay? And we have so far we have discussed this K-means clustering algorithm, which comes under partitional clustering. And some more clustering is also there, called as hierarchical clustering. So either we go from top to bottom or from bottom to top. So hierarchical clustering, again, we have 2 types. So from bottom to top, if we want to classify that, or if we want to form groups, then we call it as agglomerative clustering. And if we go from top to bottom, then it is called as divisive clustering. So we'll discuss agglomerative clustering in detail, right? Assume we are given with a data set like this, right? So say you are given with the map of, this is map of Canada, I guess. And we have so many states of Canada: Toronto, Ottawa, Vancouver, Montreal, then Winnipeg and Edmonton. So many states of Canada we have, right? And we are a problem, a use case given to us is to group the states based on their distance. So that is the use case given to us. That is the problem statement given to us. And we are given with the distance, right? And we are supposed to group them using agglomerative clustering. What is agglomerative clustering? It is nothing but grouping from leaf to top level. That is from bottom most to top level. Let us see how does it work. So I have to form a distance matrix. So between Toronto to Toronto, the distance will be 0 because on the same place means the distance will be 0. Toronto to Ottawa, it is 351. Toronto to Vancouver, it is given here. Toronto to Montreal, it is given here. Toronto to Winnipeg and Toronto to Edmonton, it is given here. Similarly, from Ottawa to other states, Vancouver to other states, from Montreal to other states, and Winnipeg to other states, Edmonton to other states, it's given here, right? And we are supposed to group them. How it is possible? Let us see. So first step, among all the distances, I have to find out the least distance, right? So the least distances, I mean the smallest distances, 167. That too, it is between Ottawa and Montreal. So they both belong to category number 1. So this is group number 1. It is Ottawa Montreal group, right? Once Ottawa and Montreal, if they belong to same group, then they should be called with a single name called as Ottawa/Montreal. So I have to reconstruct or populate or update the data set with Ottawa Montreal in a single row with that of other states. I have to find out the distance. I have to find out the distance between Toronto with that of Ottawa Montreal, Toronto to Vancouver, Toronto to Winnipeg, Toronto to Edmonton, and similarly the distance between Ottawa Montreal, that is the center point of Ottawa and Montreal with that of other states. This we have to find out, right? And among all the distances, once again I have to find out the smallest value. So this smallest value is between Ottawa, Montreal and Winnipeg. So these three belongs to the next category. So I have to combine, the next smallest distance is 351. It is between OT, MO and TO. So these three belongs to the same category. Is it okay? So this belongs to OT, MO and TO. This is group number 2. So first group is OT, MO. Second group is TO with that of OTM. Okay. Again, I have to update this table by combining OT, MO and TO. So this table will become OT, MO, TO with that of Vancouver, Winnipeg and Edmonton. Right. I have to find out the distance between each and every state. And if we are combining 3 states together, we have to find out the distance between the center point of these states with that of other points. So out of all the distances, I have to find out the least distance or the smallest distance. I have to find out the smallest value in this particular table. So this table reveals that 819 is the smallest value, which is between Vancouver and Edmonton. Again, a new set of group is formed between Vancouver and Edmonton. This is group number 3. And again, we have Vancouver, Edmonton combined with Winnipeg. This is group number 4. Finally, we have a biggest group combining the first group and that is first group TOOTMO group and VAEDWA group. It is finally combined into the topmost group, right? So this how agglomerative clustering work, right? And what is the main significant advantage of this group? We can form arbitrary number of groups. For example, if I want only 3 groups, then I can cut in this level and I can give the group as TOOTMO as one group, VAAD as one second group, and WA as third group. If I want 5 groups, that is also possible. If I want 4 groups, that is also possible. So arbitrary number of clusters is possible through hierarchical clustering. Is it okay? So that is the main difference between partial clustering and hierarchical clustering. Advantages. So does not requires predefined number of clusters. And what the diagram we draw here, we call it as dendrogram. So this dendrogram, which helps with the understanding of data, is possible in hierarchical clustering. Okay. So I have given one example in about to say partial clustering and one example in hierarchical clustering. Again, one more example we see in density-based clustering. What is density-based clustering? Based on the density of location of each parameter, we'll go for categorizing them into groups. Is it okay? So density-based clustering supports in arbitrary shaped clusters, right? So far we have seen is clustering either using spherical shapes or in elliptical shapes, but a cluster within cluster, an arbitrary shaped cluster is possible in density-based clustering. Okay. So let us, and it supports categorizing the or identifying outliers. Here we can see the gray dots are outliers, and density-based clustering supports in identifying outliers. Okay. Before moving to density-based clustering, if any doubts, you can. If you have, then you can ask me. You can represent in chat window. Yes. I think I can proceed. If no more doubt you have, then we can proceed. And till this, if you have any doubts, you can please ask me and I'm ready to answer your questions. Okay, I'll proceed. So what is DB scan? DB stands for density based scan. It is spatial clustering of application with noise, right? So how we can apply density based clustering using DB scan? So we need 2 properties. First property is called as radius of neighborhood, and second property is called as minimum number of neighbors. Okay. Assume you have these number of points in your space, and initially all these points, they are given with blue color for understanding, and all these points should be categorized randomly, arbitrarily, right, into either spherical shapes or elliptical shapes. You are going to categorize, and some outliers as it needs to be identified. That is the task given to you, and we'll see how DB scan works. And as I said, we need 2 parameters called as radius and minimum number of points, right? Now, as an input, assume you can randomly take the radius as 2 and minimum number of points M as 6. This is, we are assuming, right? This is randomly we are taking. Assume it is 2 and 6. So we are going to visit each and every point, right? So assume I am visiting that yellow point. So that is the first point. With the radius as 2, I'm going to draw a circle around this point, right? So within that circle with the radius of 2, I'm going to identify the neighboring points in the within the circle, right? So I have to go for identifying 6 neighboring points. If I have 6 number of points within the circle around this particular point, then I can say this point as border point, right? Let me come again. Each and every point should be visited. And I'm going to draw a circle with a radius of 2. So inside the circle, I'm going to examine if 6 points are available. If 6 points are available within the circle, then I can say that point is densely associated with other points. Then I can give the color of yellow to that with an assumption that it is a border point. Is it okay? So each point is a border point if it has 6 neighboring points within the circle with a radius of 2. Is it okay? So again, we'll move to the next point. We'll go for examining that point by drawing a circle with a radius of 2. If 6 points are available within the circle, then that point will be identified as a border point, right? So all the border points will be given with yellow colors, right? So border points are the points which has at least 6 neighbors within the circle. And coming to core points. Sorry. If we have 6 neighbor points, then that point will be called as a core point, and the core point will be colored with the red color, you please assume. And what would be the border point? If it is having lesser number of surrounding points, that is, in our case, we have chosen 6 as our target. If we don't have 6 points, but lesser than 6, then we can call those points as border points, right? And if it is having lesser number of neighbors, but if it is reachable from the core point, then it is called as border point. Let me come again. Each and every point we have to travel, and each and every point can be named as either core point or border point. A core point is a one which has minimum 6 neighbors within the circle of radius 2. And a border point is a one which is reachable from the core point and which is having some minimum number of surrounding points, right? So this how we'll identify all the points either through red color or yellow color. Here we have visited all the points and some more blue points are remaining there, right? And we can have a jump and start revisiting remaining points again, right? Coming to the next jump. So in the second jump, we have identified the border and core points. We can have the red point if it is having minimum 6 as its neighbor in its, including itself, minimum number of 6 points surrounding itself means it's a core point. And the remaining points, if it is reachable from the core point, then it is called as border point, right? So this how we have colored, either using yellow and red. And one more point is left out, it is in gray. We'll have a jump and we'll try to discover any neighboring points surrounds that gray color, but we don't have any such neighboring points. So it is left gray itself, right? So The first group, it is cluster 1, and the second group is cluster 2. And the leftward point, it is called as outlier. This is how DB scan works, right? So we can train arbitrary shaped clusters, and it is robust to outliers, and again does not require a prerequisite of how many number of clusters need to be used. That is also possible using DB scan. So this is how we have completed our discussion on the supervised learning algorithm. Under supervised learning, we have seen classification and regression. And under classification, we have seen K nearest neighbor classification, and regression, we have seen simple linear regression, right? And coming to unsupervised learning algorithm, we have seen clustering algorithms. So under clustering, we have seen partial clustering. Under partial clustering, we have seen K-means clustering, and one more clustering is hierarchical clustering. Under hierarchical clustering, we have seen agglomerative clustering. And the third type of clustering is density-based clustering, that is DB scan clustering. So with that, I think all the important machine learning algorithms we have visited, and we have seen at least one example for each machine learning algorithm. And before proceeding to recommended system, any doubts you have? Any doubts you have? Shall I complete? My screen is visible now. So I'll go for a recommended system. So machine learning algorithm, it supports recommended system. That is in Netflix, Amazon, Facebook, Twitter, LinkedIn, and other things. We'll go for, so whenever we use social media, automatically some recommendations are coming through the social media. So machine learning algorithm supports as a recommender. How does it work? Either it goes for content-based filtering or collaborative filtering. What is content-based filtering? Say if I am a user and I have some likes, that is in my profile, I have some likes. So if I am interested to read comic books, And content-based suggestion or content-based recommender system will support in recommending some other comics books to me. Say, for example, I'm interested in reading Harry Potter books, and the recommender system will identifies and stores my likes as interested to read Harry Potter books. Then it identifies some similar books with that with matches my interest, and go for suggesting similar interest to me, similar books to me. That is called as content-based filtering. What is collaborative filtering is, suppose if I am interested in reading comics books or Harry Potter movies or Harry Potter books, and I have some friends associated to me, and this machine learning algorithm will identify my friends list, and it recommends these books to my friends also. Or I can say it in other terms, if my friends are interested in listening music related books, then it suggests music related books to me as my friends are interested in those books. It is called as collaborative filtering because my friends are collaborators to me. So it recommends for the interest, or it recommends with the interest of my collaborators also. So it tells me what popular among my neighbors and recommends it. So these two are the famous or reputed categories of recommender systems, right? Content-based filtering and collaborative filtering. So what is content-based filtering? If I am a user and I have some likes, item 1 and item 2, then item 3, which is very similar to that of item 1 and item 2, will also be recommended to. This is content-based recommendation. How does it work? It finds the similarity among my likes. Then it would suggest similar likes to me. Right? We have different algorithms for this. And we have collaborative filtering. Again, collaborative filtering is of two types: user-based collaborating filtering and item-based collaborating filtering. User-based collaborating filtering is based on user's neighborhood. So I like these 3 books, and I have some similarity or my friends in my list, and my friend is having some similar likes, and the likes of my friends will be suggested to me. This is user-based collaborative filtering. Right. And coming to item-based collaborating filtering, if I am user 1, if I am interested in item 1 and item 3, and my friend is user 2, and she is interested in item 1 and item 3, and we have a friend user 3, then as user 1 and user 2, the majority of our interest is on item 3, then that item 3 will be recommended to user 3. So majority of our likes will be recommended to our friends as well. So this is called as collaborative filtering. So this is also possible through machine learning algorithm. Right? With that, our recommendation system is over. And what are the challenges we face with respect to collaborative filtering? If the data is very sparse, Sometimes in big data, the data sparsity will be there. So that is always a problem or a challenge for implementing collaborative filtering. And cold start, difficulty in recommendation to new users or new items, it's a challenge. And as the number of users is increasing, addressing scalability is also an issue. So these are the challenges of collaborative. Okay, so hope I have covered some basic and almost a vast domain of all the machine learning algorithms, starting from supervised, unsupervised, collaborating learning, under supervised classification and regression, and unsupervised clustering algorithms, and recommendation under recommended system, content-based filtering and collaborating filtering. So hope I have given some fundamental knowledge on machine learning algorithms. And if you have any doubts, I'm ready to support in all means. And you can have my mail ID. I have shared it in my screen. So I have completed my doctorate in machine learning algorithm. And I have come out with publications in reputed international journals, and I'm guiding 7 research scholars in machine learning. And 2 of my scholars, they have completed their comprehensive hypervoice, and I'm interested to give my support and guidance for the persons who are expecting my support, right? So I think I have to answer some more queries which are displayed in the chat box. So Mr. Abdul, he has raised a question: with the rise of AI-generated deepfakes, how can machine learning be used both to create and detect misinformation? Is there a reliable way to prevent spread of AI-generated fake content detection? Yes, of course, fake content detection is one of the problems that we can have it as a challenge. Fake content. So we have to identify some means in categorizing the actual, that is correct news. Our students, they have taken up this work using deep learning. They have categorized original image. So some keywords will be used for identifying the correctness of news, and based on some keywords. Some keywords can be identified in the fake news, and that can be defined as a fake news. One of our student batch, they have completed in taking this this as a project to categorize fake news and original news. And again, how it is, how it can prevent or identify AI generated. So from AI generated, we have to identify based on the keyword generated through AI content. So that is the only way of solution as of now we have identified, right? And one more question: many companies integrate machine learning into their customer service, chatbots and virtual. Yes, you are correct. Can AI truly replace human interaction in customer support or the? And no, so many inbuilt generated Gemini AI we have used. AI truly replace human interaction in customer support? Are there any limitations that prevent full automation? No, so many challenges still challenges and limitations we face in implementing machine learning algorithms, I could say. Always 100% replacement for human is still not yet evolved. We are in the learning and growing phase. We have used so many automation algorithms which can come out with decision making, but 100% replacement, I think it is not always possible to replace a human being. Again, Mr. Kinan, he has asked one question. Data is the foundation of machine learning, but not algorithm. I think I have answered this question already. Okay. So any more questions? Even though offline, you can connect me through posting my queries in my mail, through my mail. My mail ID is hodcse@kamaraj.engg.edu.in. One more question I think I have got. Okay, that's enough from us, ma'am. Thank you for your answer. Thank you. And once again, I thank the organizers from STEKOM University for giving me an opportunity to share my ideas in machine learning and applications. Hope our association will go and will continue in future, and we are ready to extend our support in all the ways possible, and again expect your cooperation and our association from STEKOM University as well. So thank you so much, and it was very nice and wonderful experience to me in sharing my ideas. And thank you once again. Thank you.
Thank you so much for your presentation.
Thank you all. Thank you.
Before I proceed, and for our participant, please open your camera. I will take a picture on the count of three. Okay, 1, 2, 3. Okay, another one. 1, 2, 3. Thank you. Thank you for your cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Dr. Meenakshi for the wonderful information in sharing the knowledge. We hope this information will be beneficial to our participants. At least we hope to for collaboration in the future with Kamaraj Engineering College. The visiting lecture for today and here we proceed. Thank you and have a nice day.